The Human-Computer Interaction Institute is a department within the School of Computer Science at Carnegie Mellon University in Pittsburgh, Pennsylvania. It is considered one of the leading centers of human-computer interaction research, and was named one of the top 10 most innovative schools in information technology by Computer World in 2008. For the past 3 decades, the Institute has been the predominant publishing force at leading HCI venues, most notably ACM Chi, where it regularly contributes more than 10% of the papers. Research at the Institute aims to understand and create technology that harmonizes with and improves human capabilities by integrating aspects of computer science, design, social science, and learning science. HCI offers human-computer interaction as an additional major for undergraduates, as well as a master's degree and PhDs in HCI. Students from various academic backgrounds come together from around the world to participate in this program. Students hold undergraduate degrees in psychology, design, and computer science, as well as many others. Students enter the program at various stages in their academic and professional careers. HCI research and educational programs span a full cycle of knowledge creation. The cycle includes research on how people work, play, and communicate within groups, organizations, and social structures. It includes the design, creation, and evaluation of technologies and tools to support human and social activities. History. The idea for a Human-Computer Interaction Institute can be traced back to 1967, with the founding of the Computer Science program at CMU. Founders Alan Newell, Herbert A. Simon, and Alan J. Perlis believed that the new discipline of computer science should include the study of phenomena surrounding computers, not just the theory and design of computation devices themselves. In 1985, Bonnie John opened the first user study laboratories for faculty and student use, and the department was officially established in 1993 when John offered the first CMU course in human-computer interaction. The HCI Master's program began in 1995, the undergraduate major began in 1997, and the doctoral program, the first in the United States to offer a PhD in HCI, began in 2000. Academics. The HCI department at CMU offers multidisciplinary undergraduate and graduate educational programs that emphasize technology for the benefit of people and society. With membership from Carnegie Mellon's School of Computer Science, the College of Fine Arts, the Tepper School of Business, the Dietrich College of Humanities and Social Sciences, the Robotics Institute, and the Software Engineering Institute. The HCI is one of the few institutions in the country with the breadth of expertise to offer such programs. Undergraduate program. The undergraduate major in HCI offered by the department is available only as a second major. The program is devoted to the design, implementation, and evaluation of interactive computer-based technology. This includes products such as intelligent computer tutors, wearable computers, and highly interactive websites. The undergraduate curriculum concentrates on the 3 main stages that form the cyclic and iterative process of constructing an HCI product. This includes the design stage, which involves studying the principles of human behavior and understanding how human factors and cognitive models should inform design. Students also learn about communication design and understand how implementation constraints should inform design as part of this phase. Next comes the implementation stage, where students are taught the principles of computer science. This involves becoming familiar with different programming languages and learning about various algorithms and data structures. Lastly, the students learn about the evaluation process, which involves usability testing and statistical analysis of the constructed product. Hence the undergraduate program covers the 4 topical areas of human behavior: design, implementation, and evaluation. The HCII department offers over 100 elective courses relevant to these areas that are offered by 8 different departments in 4 different colleges at CMU. The HCI undergraduate program also offers the possibility for the accelerated master's program in HCI. Eligible students must be finishing their degree in HCI and begin master's program the last semester of their senior year, working with a capstone group through the entire year and taking electives. Students can finish their Masters in Human-Computer Interaction in 2 extra semesters instead of 3. Master's program. The Human-Computer Interaction Institute at Carnegie Mellon University also offers a professional Master of Human-Computer Interaction degree as well as the Masters in Educational Technology and Applied Learning Science. The HCII's Master's program is known by the software and technical industries for its interdisciplinary nature, rigor and deep knowledge in computer science, psychology and design. It is a 2-year master's degree set into a 12-month duration. During their first semester, students learn core knowledge in programming, design, psychology and HCI methods. During their second and third semesters, students are allowed to choose any electives across the university, while they participate in a substantial industry capstone project with an external client. The HCI Institute also offers a dual degree program in collaboration with the University of Madeira, launched in the fall of 2007. The Madeira program is set into a 16-month duration divided into 3 semesters with the inclusion of a summer break in the academic calendar. The students spend the first semester at Carnegie Mellon University and the remaining 2 at the University of Madeira's Madeira Interactive Technologies Institute. The MHCI Capstone Project course provides students with the unique opportunity to apply all of the skills they obtain from the MHCI program. It provides a real-life opportunity, similar to an actual experience in a research, design or development setting. The 32-week-long course is divided into 2 halves. The first half focuses on getting to know the sponsor and its company, setting scope, secondary research like competitive analysis, and user research. The second half involves an ideation phase, where students take the data they found in the first half and work to design a prototype that they believe will meet the needs, desires and problems of the users. The students are expected to spend the remainder of the course iteratively programming and testing their chosen design. At the end of the capstone project, the students are expected to produce a designed, developed and tested prototype. At the end of the 12 months, students are expected to be able to effectively lead and collaborate in the design and implementation of easy, desirable, and thoughtful software and technical systems. Students are taught to contribute to the multidisciplinary teams that typically construct software and technical systems and interfaces. Students learn about techniques for building successful user interfaces, design principles that make user interfaces visually clear and appealing, techniques for identifying needs for software and its success, and the people and organizations that will use their systems. Over the past 17 years, the program has graduated over 520 students. Right out of school, students graduation from the HCI Master's program have taken on various roles in technical and software companies. Some of these include interaction designer, usability engineer, design team lead, user researcher, and user experience designer. Alumni from the MHCI program have gone on to become senior designers, technical directors, usability and design group leaders, senior product or project managers and CEOs. The Masters in Educational Technology and Applied Learning Science. This is an interdisciplinary program jointly taught by the Human-Computer Interaction in the School of Computer Science and Psychology in Dietrich College of Humanities and Social Sciences. The program is an outgrowth of the extensive research conducted by the National Science Foundation's Science of Learning Center, LearnLab, in which more than 200 researchers produce over 1,600 publications and talks. Metals offers students who have a bachelor's or master's degree in psychology, education, computer science, information technology, business, or design the opportunity to improve their training with advanced study in educational technology and applied learning science. Our students will gain the knowledge, skills, and techniques to develop and evaluate programs in learning settings that range from schools to workplaces, museums to computer-based environments, as well as other formal, informal and non-traditional educational settings. Graduates of the program will take key positions in corporations and private and public universities and schools. They will become designers, developers, and evaluators of educational technologies and learning environments, as well as domain experts, learning technology policymakers, or even chief learning officers. The program integrates fundamental skills with project-based studio classes culminating in a final capstone project. Many students will choose Carnegie Mellon metals on the basis of the practical experience the capstone project provides. The course curriculum is structured to cover the end-to-end process of a research and development product cycle, while working closely with a corporate sponsor on new ideas or applications that may work with their existing human-to-machine technology. The goal of this 32-week course is to give each student two opportunities. The first is to apply all of the skills they obtain from the metals program, and the second is a real-life opportunity, similar to an actual experience in a research, design, development setting. Upon completion of the Masters in Educational Technology and Applied Learning Science, graduates will be able to design, develop, and implement advanced educational solutions that make use of state-of-the-art technologies and methods such as artificial intelligence, machine learning, language technologies, intelligent tutoring systems, educational data mining, tangible interfaces. Understand how these technologies can be applied to engineer and implement innovative and effective educational solutions. Understand cognitive and social psychology principles relevant to research-informed instructional design. Have skills for instructional and interaction design needed to create solutions that not only enhance learning, but are also desirable. Be able to develop continual improvement programs that employ in vivo experiments and educational data mining to reliably identify best practices and opportunities for change. PhD program. The Human-Computer Interaction PhD program offered by the HCII department was established in the fall of 2000. The program aims at teaching students how to make computers easy to use, and understanding how computing affects people. Since HCI encompasses aspects both people and technology, the program takes a strongly interdisciplinary approach. The HCII brings scientific and engineering knowledge from computing together with that of the behavioral sciences, such as psychology and the social sciences. Further, in order to produce efficient, effective, and pleasing technology, this scientific basis is also combined with the integrative methods of the discipline of design, which are directed towards the conception of total products, mirroring this diversity. The program encourages applicants from a range of disciplines and fields. Students accepted to the PhD program participate in the wide-ranging and innovative research programs offered by the Institute. HCI PhD students are given full access to the excellent computational and laboratory facilities of the School of Computer Science and the HCI Institute, as well as facilities of the Department of Psychology and the School of Design. In addition to wide-ranging research opportunities, students will have the opportunity to explore a rich set of coursework and other activities designed to prepare them for a career in HCI research. Requirements for the PhD course of study are designed to accommodate students with a range of backgrounds by providing several different tracks of study. Finally, The institute anticipates that all students accepted to the HCI PhD program will be awarded a graduate fellowship covering full tuition and a living allowance. In order to complete a PhD in HCI, candidates are expected to complete requirements in 3 areas. These include research, coursework and teaching. The PhD program is designed first and foremost to teach students how to carry out original high-quality research in human-computer interaction. The primary requirement in this area is the proposal and defense of a dissertation describing original research. In addition, the program includes a research presentation skills requirement that requires candidates to present original research to the HCI Institute community, in written and oral form in the first 2 years of study. The program uses an apprenticeship-based approach in which students are teamed with an initial research advisor who guides and monitors the work and research done by the student. The institute expects that all students will become involved in an HCI research project from the beginning, and continue research work throughout their course of study. The program of study culminates in a dissertation describing original research. Proposal and defense of this dissertation are primary requirements for obtaining a PhD in HCI. The second area of required study by the PhD program is coursework. To accommodate students with a wide range of interests, the program has been structured around 3 areas of specialization: human sciences, computer science, and design. These areas of specialization each have different specific course requirements. Conducting research requires a firm grounding in the concepts and prior work of a field. Coursework requirements are designed to ensure that firm grounding. Course requirements are structured so that they can typically be completed within the first 2.5 years of study. However, students are free to schedule their coursework in a variety of ways to accommodate their educational needs, and in some cases additional prerequisite coursework may be needed. Lastly, students are expected to complete a teaching requirement. The program aims at helping students learn the skills necessary to teach, such as organizing and presenting complex materials clearly, as they are important for all researchers. To help PhD candidates develop these skills, the program requires each student to serve as a teaching assistant for 2 semesters sometime during their program of study. Research. The Human-Computer Interaction Institute at Carnegie Mellon University has a long history of successful research projects. Carnegie Mellon was one of the first universities to conduct research in human-computer interaction. The Human-Computer Interaction Institute at Carnegie Mellon University was formed in 1994 to foster multidisciplinary research and education in the area of human-computer interaction. Some research topics include user interface software tools, cognitive models, speech recognition, natural language understanding, computer graphics, gesture recognition, data visualization, intelligent agents, visual interface design, multimedia, computer-supported cooperative work, computer music and drama, intelligent tutors, technical writing, and the organizational and social impact of technology. Some fields in which notable research is currently being done at the HCI are learning technologies, tools and technology, human assistance, robotics, arts and entertainment, and the Entertainment Media Center. Some notable research projects in the HCII department are ACT-R by Dr. John Anderson, Step Green by Jennifer Mankoff, Pebbles by Brad Myers, and the Pittsburgh Advanced Cognitive Tutor. ACT-R. The ACT-R project is focused on the development of a robust and general cognitive architecture and its application to the modeling of human interaction with complex dynamic simulated environments and the creation of synthetic human-like agents. It is mainly about cognitive architecture, a theory about how human cognition works. On the exterior, ACT-R looks like a programming language, however, its constructs reflect assumptions about human cognition. These assumptions are based on numerous facts derived from psychology experiments. ACTAR has been applied to cognitive psychology, HCI, education, and neuropsychology. STEP Green is an umbrella project that brings research from several disciplines including behavioral science, environmental engineering, and computer science. STEP Green's goal is to understand and address the problems inherent in changing energy consumption behavior. An important goal of the project is to deploy widely, reach critical mass, and study these factors in the field. One way STEP Green plans to accomplish this is by using their website to encourage individuals to reduce their energy consumption by leveraging online social networks. Pebbles. The Pebbles project is exploring how personal digital assistants, such as the Palm handheld or a device running the Microsoft Windows CE or Pocket PC operating systems, can be used when they are communicating with a regular personal computer, with other PDAs, and with computerized devices such as telephones, radios, microwave ovens and factory equipment. Pittsburgh Advanced Cognitive Tutor. The PACT Center does research in cognitive psychology to create cognitive tutor technology and to create better classroom curricula. The PACT Center uses cognitive tutor technology to create an integrated classroom and computer lab curriculum that supports students' understanding of mathematical and real-world concepts. Based on a computational model of thought, cognitive tutors can automatically generate the most sensible solutions to any given problem, follow students step by step as they work, and provide individualized feedback or advice. One product of the PACT Center that has been successful is the Cognitive Tutor Algebra. In the fall of 2004, the U.S. Department of Education, What Works Clearinghouse, analyzed research studies on 44 math programs used in grades 6 to 9. Cognitive Tutor Algebra was one of only 2 of these programs that both met the high standards of the clearinghouse and provided quality evidence that students learn more from these programs than from other programs.